In the last video, we developed the sheet for calculating the switching value of costs. Now this sheet deals with the switching value of benefits, which will be based on the stream that we have used before of Lahore-Sialkot motorway project. So we can refer to the previous videos for the values of the costs and the benefits that we have listed here again. This will be the discounting factor if we consider that it is 12%. Now the experiment is that we are going to decrease the costs by a certain percentage, and here you will see that we will experiment with two levels, that is the first level 36% and the other one is 41%, and we will keep it in such a way that the gap between the two remains at maximum 5%, because that is the convention of the interpolation formula. So 36% change or decrease in the benefits is being calculated here. As you can see, benefits the original value, and 36% of the benefits original value is deducted from it, and we will get 0 because it is already 0. So for this it will remain 0 all these 3 years. But here you can see that 20 becomes 12.8, and that is true because 36% of 20 is subtracted from it. Here 36% of 30 is subtracted from it, and 36% of 50 is subtracted from it. So in this way we get the certain new levels of the costs. Benefits, which are the which are lower than the original benefits because they are unexpectedly decreased. Now the higher level of the decrease in the benefits can be calculated in the same way. The formula should be considered here. The original benefits subtracted the 41% of the original benefits from it, we get this. And now we have this formula being applied in the last row, that is 50 minus this. This is again the verification of the formula if it is true or not, and it seems that it is true. So now we can use both of these new benefits columns to calculate the net benefits at lower change in cost and at higher change in cost. In case of lower change in cost, we will be using the first column that we developed, and we will take the difference with costs, this original cost column, because in sensitivity analysis we change only one of the variables at one point in analysis. That is the new benefits with lower change and the original costs that are in red color. Let's verify if the selection is correct. The new benefits after lower change in them, and the old costs, we take the difference, we get this series of values, and when we add them we get the NPV by discounting them at 12%, which is positive. And then we calculate the net benefits at higher change in the net benefit in the benefits, and this is equal to the higher the new value of the benefits with higher decrease in the benefits minus the costs. And we can see that we have chosen the correct cells. By choosing the final year's value, we verify that this is the benefits column and the cell is the correct one, and this is the cost column, and again the cell is the correct one. Now we can apply the NPV formula here that we have applied. By taking 12% as the discount rate, we have found the NPV, which is negative. Now this fulfills the requirement of interpolation, that we have one positive NPV and one negative NPV. So we do the interpolation here, the formula for which is explained already in the last video. Here again we are observing that we are requiring a condition to be fulfilled, and it's a couple of conditions that should be fulfilled simultaneously, that the first NPV should be positive and the second NPV should be negative. And if both of these conditions are fulfilled, then we do the interpolation, otherwise we don't. This is the lower decrease in the benefits, higher decrease in the benefits, lower decrease in the benefits, NPV at lower decrease in benefits, NPV at lower decrease in benefits, NPV at higher decrease in the benefits in its absolute terms. And once we enter these values, we get the interpolation results that show that 38.7510% decrease in the benefits would lead NPV to 0. So we choose this switching value of benefits and we calculate the NPV on the basis of it. So this is the series of net benefits after using the switching value of benefits in the calculation. So you see that we are going to choose the benefits value, going to subtract from the benefits value its decline by the switching value of benefits element, which is 38.71, or which is in I14th cell, minus the old cost that is in F3, as you can see. So this will be the first column. It doesn't have any change because the benefits are 0, so no matter how much we decline them, they will remain the same. So they are as the original net benefits were, but this will change because in this case there is a decline in the net in the benefits by 38.7510%. As you can see in the red color, it is shown the switching value, and this is the benefits value. This change in the benefits will be subtracted from the actual value of the benefits, and then we subtract the F6, which is the cost, the original one. So now we get this row of this column of values that we can add, and then take the discounting factor as 12% to find its value of NPV, and it is equal to 0. It means that the value that we have found, the switching value of benefits, this value is correct because it is getting verified that at this decline in the benefits, the NPV will turn to 0. And as a project manager, one should try to keep on the eye on the decline in the benefits and should not let the benefits decline surpass this level. In the next video, we will do the experimentation with the discount rate. Thank you.